Okay, now we are solving this question by integrating by parts. This is u is x because it's an algebraic equation, and we take its derivative. This is dv is this part, and we take its integral here. Now here we multiply uv here, this one, and we say minus integral of this part over here. This is minus cosinus x dx, and integral of minus cosinus x dx minus is equal to sinus x. So our answer will be this one for this integration. Now, example 3. Let us see this one. Again, it's the same. This is algebraic function, okay? This one is algebraic function, and this is exponential. So, algebraic functions, according to Lie 8 formula, let us look to this formula over here. Lie 8, you can see this formula. Okay, in this formula, algebraic functions comes first, okay? Then the exponential functions. If we have algebraic functions, then we say they are u. This Lie 8 is for choosing u. So we have an algebraic function, we say it's u. Here, it's u. Okay, and now we have dv. The rest is dv here. This part is dv. Okay, so we are going to take derivative of this one and integral of this blue one. Here we write it. Okay, so this is a special case. Okay, in this part we do it like this because as we say in the winding above, sometimes when we notice that we cannot find the solution. Okay, how we notice it? Because here when we take the integral of this part, let us look. This is a equation where the integration by parts doesn't apply the exact formula, so we have to follow a new technique for that. So we separate this x3 to two parts, okay? And we take x here. Why we do it? Because when we take integral of this one, we see that integral of this one equals to 1 over 2e to the power x to the power 2. So in order to find integral of this one, we need an x here to reach this result. And in this part, we have u equals to x squared. So we take derivative of it and it becomes 2x. Now we can apply the same formula and we can get this x squared minus 1 over 2 e x to the power 2. It should be somewhere here. Yes, here. This is x squared, this part that you can see here, uv. Okay, and we are going to subtract this blue part from that. The reason that we divide this one again, because in order to take integral of this part, we need an x. Okay, that's why when we notice it, we divide it into 2. We write x to the power 2 multiply x, and here we take some part of this to dv. We didn't take exactly x to the power 3, but we divide it into two parts. X to the power 2 multiply x to the power 1. And we get this. Here this is uv minus integral of this, as I say, 1 over 2 e to the power x, this part. You can watch it. This part, this multiplication of this part here, v du. Okay, and we reach to this conclusion. Okay, so here, let us see another method. This is called tabular integration by parts. Okay, Now, this method above is integration by parts. By choosing u and v, I am going to up the first page again. Here in this part, okay, in this part you can see that we use it according to the Lie 8. We decide what is u, what is dv, and in this method, according to Lie TE method, we take derivative of this u and we take integral of this v dv. Okay, but sometimes we have to divide like this in order to find a proper solution. This was one way of integration by parts. Now we are seeing another way, and this is tabular integration method. In this method, okay, again we find u and dv. Okay, so here u and dv. In this tabular integration, we take u as it is according to rules. This is algebraic one, so we choose x to the power 3, and the rest one we say we take integrals of sinus x dx. Okay, and sinus x dx is minus cosinus x. So again we take integral of minus cosinus x and we get minus sinus x. We take one more integral of minus sinus x, we get cosinus x. One more integral of cosinus x, so this is about that, we get sinus x. Here in this part we take derivatives. Derivative of x to the power 3 is 3x to the power 2, and derivative of this one is 6x. Derivative of this one is 6, derivative of 6 is 0. So this goes until we get this 0 here. Aim is getting 0 in the table of u. So until we get 0, we take integral of the other part. Now, what is our solution? In the solution part, we use this method. Look here, we cross multiply. Okay, we cross multiply. We multiply x to the power 3 by cosinus x. X to the power 3. We multiply it by cosinus x here. Okay, is here you can see. By the way, here we apply plus, minus, plus signs. Alternating signs. We apply it by alternating signs. So first of all we have plus, then we have minus. Okay, multiply by this 3 to the power x to the 2, 3x to the power 2. With this one here is minus sinus x. Okay, so you can see this green one's multiplication here. You can see this green one's here. Okay, and here this is 6x. This part is 6x here. This part is 6x multiplied by cosinus x. Okay, the blue ones. Here this 6x multiplied by cosinus x. You can see this one here. But the way is plus. Okay, we always have this plus, minus, it goes like that. This is a rule, this is called tabular rule for finding integrals. It goes with plus, minus, then plus. We have a plus here, and we have a minus here. It's an easy method, in fact, it's not hard. But we have to know different methods of integration. We have to know the other method and this method. The most important thing is choosing u. Okay, once you choose u and you take derivative of it until you get 0, you take integral of the other part, the rest is easy. As you can see, the last one, 6 is multiplied by, let me make this yellow. This is sinus x, 6 sinus x. Here you can see it, 6 sinus x. Okay, plus C. So this is the solution of this integral here. All we do, once again, we separate it into parts. This is again separation of parts by tabular method. We use tables and we use this tabular method here, and we take, once again, take derivative until we get 0. We take integral. So we don't stop taking integral until this is 0 here, and then we cross multiply, and we put plus minus, and this is our solution. And simplifying, we get this answer. If we simplify it, simplifying by I mean multiplying these pluses, minuses, and all the other stuff, here we get this solution. Okay, this was tabulation method. So I have also this tabulation method here. Okay. Once again, let us watch it from here, this tabulation method. Are you following me, by the way? So we start recording again. So what I have just explained was tabulation by parts. Okay, so just a moment. Okay, we were here. I have just finished this part here. Now I am going to explain it again. Okay, so yes, here. Okay, I was explaining Lee 8 method, tabular integration by parts method. Okay, here. And in this method, there is an order, Lee 8. By the way, can you hear my voice? Please open your microphones and say, confirm that you are hearing or not. Can I hear your voice? You can. Okay. Thank you very much. So I can continue explaining. Damla, are you okay? Damla, can I hear your voice? Can you hear me? No? Ferhat, can you hear me? Okay, thank you. And you can see my screen? Yes. Okay, good. So if there is any problem, please feel free to say me, teacher, we cannot hear you, teacher, we cannot see screen, okay? Now, here, this is Lee 8 method. In this method, what is important is that the order is important. So this is a method for choosing U. Okay, this is a method for choosing U. We choose U, L, E, T, E. L stands for logarithmic functions. For example, ln x, logarithm 2x. These are ln functions. If there is any functions like this, we say it is U. If we don't have logarithmic functions, the next thing that we look is inverse logarithmic functions. Yes. Okay, you cannot see my screen. Okay. In this tabular method here, okay, again, there is a trigonometric function here, and there is an algebraic function. Okay, there are two things. Let me have a slideshow from current slide. Okay, here. So okay. Just a minute. I cannot see the end of the question, so anyway, let us continue like this. Okay, here, this is x to the power 2 sinus 4x. I need some stuff for showing, that's why that I was looking. Now I have this, just a moment. Yes, I have this stuff here. Okay, here, This is x to the power 2. We choose this x to the power 2 as u because it's algebraic, and this one, this part, we choose it as dv. Okay, in tabular form we don't write this dx. Okay, in the other method we write dx, but in tabular form we don't write dx. Okay, here we take derivative until we get 0. Okay, we get derivative until we get 0, and here we take integral until this derivative is 0, and then we multiply, we cross multiply x squared by this minus 1 over 4 cos 4x, this one by this one, and the 2 by this one, and then our answer will be this one. Our answer will be this one minus 1. Look, let us look at this. Here x squared and minus 1 over 4 cos x, this is the first part. Okay, but in front we have plus sign, but the minus comes from here, you can see. Okay, and here we have minus. Okay, but we have minus here also, so that's why it is plus. And this part is the cross multiplication of the last arrows here. It is 2 multiplied by 1 over 64 cosine 4x, and here you can see that, wait, this is 2, yes, okay. So there is a plus sign in here, so we have a plus sign. Okay, so we look to the signs in the starting point of the arrow, and this is called tabular method. Yes, do you have any questions until now? The tabular methods and rest of what we say today. Okay, today we see two methods. Okay, the first method is this one. We decide u and dv. Okay, and we write it like this: u multiplied by v, okay, minus integral v du. And here the important thing is that choosing what is u and what is dv. Okay, the important thing is choosing u and dv. I'm going to take some shapes for showing. Okay, so here, okay, now we choose x again here because it is an algebraic expression, x, and this is an exponential expression. It comes after the algebraic expansion in the Lie formula. Here this is x, so this is dv. We always take derivative of this and we take integral of the other one, and we use this formula. In this formula, u v multiplied by uv and v du. V du is here, okay, v du, so we multiply this one and this is v du. So this is the first method, okay, this formula is the first method, this formula over here is the first method. Now the second method that we see for integration by parts is the Lie formula is also in this slide. Lie formula, logarithmic inverse, trigonometric algebra, trigonometric exponential. That's for choosing u. If we have logarithmic, we were choosing u as logarithmic. If inverse algebraic, okay, this is the order. So the first one, if we have logarithmic, we choose it logarithmic, not the exponential. We may have also exponential, but we choose the logarithmic. This is in order, okay. So here, order of choosing u. Now this is tabular method. In tabular method, what we do is, again, first of all, of course, the Lie formula is valid for this method also, this tabular method. And in this method, what we do, we choose x squared, we choose it this is an algebraic equation here, and we choose it u as x squared. That's right. In both of the formulas, in the first formula, integration by parts, in the tabular formula, this is the same. This is algebraic and this is trigonometric. It comes later in the late formula. Here, this is x squared. Okay, we take its derivative until we get 0. Okay, we continue taking derivatives. It's not important whether we have here 5 steps, 7, 8, 9, 10, 11. We continue until we get 0. Okay, after some point, always derivative gets 0 here. And in this part, this is other part. We don't write dx in the tabular method. We just write the left, what is left after taking u. Sinus 4x left here. So I write sinus 4x here and I start taking integral of it. Okay? I take integral of sinus 4x, it becomes this. I take one more integral, it becomes this. I take one more integral, it becomes this. Okay? So I continue taking integral of it until I have 0 on the left side of the table. And after that, this is a method that applies for all the equations where we can divide in the form of u and dv. There are equations which we cannot divide. We will talk them later. So this applies in all the cases where we can write u, dv, we can separate. And this is alternating signs. It means that we have to write plus, minus, plus, minus. And we have to do cross multiplication. You can see this here. We have to do cross multiplication. X squared minus 1 over 4 cos 4x minus 1 over 4 x squared cos x. It's just at here. Okay, this part. And then I have 2x and minus 1 over 16 sinus 4x, okay, and it's here, but I have to multiply with minus, okay, minus multiply by minus, it becomes plus. So I always use the signs here. Now the sign is plus, okay, and here I multiply 2 by 1 over 64 cosine 4x, and I get it like this. So this is my result of the equation here.